Hello everybody, welcome to another stream. Um, so last stream we didn't really actually work on the Gizmo stuff. We actually worked on adding like the editor system and sort of tackling the gizmos from the other side where it's like how are we actually going to use them. So we sort of made the editor files and got them set up, and we also sort of moved some code into the engine, like the camera code and the draw code as well for the debug drawing stuff, because I wanted to have a separate version which worked in the editor, so we sort of made it work in the editor as well. So now the editor's all kind of, or the foundations for the editor is all there. We can get back to doing gizmos now. So yeah, I hope everyone's having a good day so far. I started working on quickly adding arrayverse plane code in because I was quickly trying to put in the draw 3D stuff for a plane. So we're just going to finish that up. We can debug draw a plane, and we're going to use that to help do stuff for to debug the input handling code for the gizmos. So that's the only thing we're going to work on now. Hey Lupo, how are you doing? Good to see you. So this is a function that I took from this guy, Inigo Qualez. He's got his range section stuff, he's got his SDF stuff. But I'm just going to change it a little bit. So it expects like array origin. So, and then array direction. And then some normal. And it's meant to be normalized around what's interesting is he adds to the dot product. So, yeah, I was playing around with it. It seems like it adds. I changed the box intersection code one for this. It seems like it makes things for the plane smoother around the edge type of thing. It's weird. I don't know. I have no idea why. We're not going to have it though. So I was thinking about maybe doing like a position and then have it like automatically work out the relative position. Or the vector towards the plane. Towards the ray origin type of thing. It's like a hobby personal project, right? Yeah. Yeah. Personal project, hobby project. For quite a few reasons. How about you? Have you got your own personal project? So the way this code works is that it used to expect it to be positioned to be at 0, 0. So P was just a normal. So R and P is still a normal. We'll make it normal. But R O, so the ray origin, used to be relative from the center point. So we need to now to make that. So we're saying going towards ray origin from position. And now we get something called vec. So we can place RO with vec, P with normal, and then that should be the plane, reverse plane code. So we can share that between CPU and GPU code, which is going to be useful because we want to use it for both CPU and GPU. So inside the shader code, where we do the debug drawing stuff, we've got those parameters passed in. Yeah, it'd be interesting if you can get, well, the normal is always just going to be whatever normal is, right? Obviously. We might hit the back side of the plane. Yeah, ooh, that's interesting. Well, the normal would be whatever the sign is of ray origin. That's what the normal would be. It's quite simple. Yes, ray versus plane, you get back a T. So ray origin, what did I call that? Ray origin v space, ray direction v space, position of the plane, and the normal. Cool. So if we get hit in view space, if it's the new closest one, jobs are given. Output the color, and the normal. Normal in view space is simply the sign, the copy sign. Is that right? No, you know what would be nice is if we can code the normal in there as well. The normal would be YZW, you know? So whatever the sign is of that. T return T return dot x equal T return dot YZW is copy sign. No. Yeah, the back facing plane normal. Maybe I'm wrong. It's not, might not be copy sign. Oh, we'll do it. You got a plane like that. Your normal's like that. Got a ray origin. It might be the dot product. Yeah, it's the dot product, isn't it? Oh, awesome. Check out the Adam sec. Thank you. Because you had a normal on the numerator and denominator, the signs can cancel. It might not matter. Well, the thing is though, when you do, you need the normal for shading purposes. Like you always want, the normal's always going to be the same no matter what you hit on it. But it's just whatever side you hit. Like, yeah, you want to write normal. I think you just dot product it basically. So it'll be if the dot is negative, something like it might be something like multiply whatever normal is with the sine of the dot between normal and vec. Probably normalized. Something silly like that. Or we compute the correct normal for the reverse plane, because I think we do some lighting on it. So we want the correct normal. So if your ray origin is from this side, you want that. Whereas if your ray origin is from this side, you want that normal. So I think we multiply the normal by either -1 or 1 based on the dot products between the normal, which is this guy, and the normalized vector to the ray origin. So that'll be that one. So if they point opposite directions, the dot product is -1. This will be in the negatives. This will be in the positives, right? So then you sign it so it snaps it to -1 or 1, and then multiply that normal. So if you flip it or don't flip it, install that in W. I think that'll do it. It would normalize won't change the sign. Awesome. Yeah, I thought that might be the case, but I wanted to be safe because I don't really know. But thank you for clearing that up. So now I know. Awesome. So that'll be less intensive there, which would be pretty cool. Yeah, so now we've got our super reverse plane function. We can get the result here. Or hit, I usually call it. Let's be hit dot, what is it, W. Hit T, view space, hit dot X. Right, that should be it. So shall we try and see how that goes? There's a, so in the editor, we can now put a debug drawing for a plane. Right, I can just be like, yeah, what might be cool is if we could like shape the plane based on distance from the center or something. You know, maybe could be an interesting thing to do. I don't know. So I think we want called like game underscore draw 3D. So I added this quickly, so hopefully it works. Draw 3D plane in world space. Now let's let it sit just above the ground, and we'll make it go below the ground. Or maybe we'll make it move up and down from like really far below so we don't cut stuff off. They've already got rendering. So let's say we've got an X of 0 and a Y of 0. And let's say we've got like a -8 plus some kind of sign. We haven't got that time, have we? Right, let's accumulate some time. Multiplied by 4. I'll do it. Cool, so that will get us a position. The normal, let's just make it point directly up. And then we'll do a lovely red as a color. And we will not Z test, because I think that's broken. So if we try that, hopefully the computer doesn't blow up. That's number one. Sorry, I usually zoom in a bit, I think. Yeah, there we go. That's better. So yeah, the stream dials are back. I've changed GPU code, but it should not die because, you know, I think it's all right. All right. We just see red. This is not to be expected. So I think it's because our hit T... Well, I have no idea, actually. Well... So we could start off with the view space one, because the view space one does do a transformation from wall space to view space. Vector going towards ray origin, that makes sense from position. The pause is not being used anywhere. Ray origins are used in one place. Seems pretty sensible to me. Yeah, I didn't change anything too much. Okay. So I guess let's follow the code through and make sure it makes sense. Yeah, so we're reading in this many words. That's what we pass in, I think. We can double check that. Reverse plane, position goes there, the normal, yep. Right. Yeah, so then it's yeah, that seems all okay. So let's go into the game.c where we've written out that plane. It's the plane wall space uses this one. And then in that sort of wrong file, draw.c. We allocate 8 words, plane, position xy, normal xy, z. Hello, that's good. Then the world space one is going to move them into view space before it adds them in. And that seems okay. You know, this is using multiply vector, so just as rotation and scale. This one does position as well. That seems sensible. I think we're setting this the view from world at the right time. Where's the camera get updated? Up here. The view from world's getting set there. Right, but the mouse is not visible. It might be set. Super effective. Interesting. Yeah, maybe scaling. Yeah, it should be normalized, shouldn't it? We should normalize them. Yeah, just rotations. Yeah, the thing is though, it's with a matrix. So you it's with a matrix. So you only get so your scale and translation are munched together. That being said, I don't think I've scaled my view from world, but that could probably be problematic later on. Yeah, I should keep an eye on that. Should probably normalize it. But I've got another thing which does the I've got another utility called the transform 3D, and it keeps them separate. So you can do things like just apply the rotation manually. But yeah, it's with a quaternion and then you flip the sign. That's quite handy. So those operations in that are technically quicker. Wait, maybe they might not be because of... Yeah. Could be about the same. I'm not sure. No, because with the matrix it's just... Yeah, I forget. I've got like a mole V. Yeah, because that's the matrix one. Yeah, the matrix one is definitely still quicker. But yeah, it'll munch the rotation and scale together at the same time. There's no avoiding that, and then you have to normalize it. Whoopsie. Yeah, so I'll look into that quick. So mol v. Yeah, that's fine. That's a vectors, that's okay. The thickness, this one's a normal. Right, so apparently that's the only one that did it. Oh, draw 3D render light direction. What's this light direction? Right, that's pretty sweet. And what's transform as the inverse transpose? As the inverse transpose of the matrix, but for rotations, the transpose is the inverse, so it cancels it out. But say for rotations, the transpose is the inverse, so it cancels it out. Yeah, I'm a little bit confused by what you just said, to be honest. I don't really understand. Yeah, I don't quite follow. Right, I think we caught those out now. Not quite. Another one here. Another direction. So, hmm. Cool. All right, I think we're there. So why doesn't this plane one want to work? So we can try the view space one for now. See what happens. Let's do in view space. Perhaps gonna hear more P matrix adding. Right, maybe we can make it a disk. If we take the radius of the hit position or something, we can do it as a disk. So it should be a little bit easier to work with. So a disk is right. This extra line here. Perhaps we could try that one out. This isn't core shared, won't it? Oh, my laptop died, damn it. Right, I might take a look at it later. Yeah, a bit much to process right now, but yeah, thank you. I'll look at it later and see if I can understand it. Appreciate it. Let's try this album out. Video not available? Right, apparently it's been banned by Kistama. My apologies. Um... I'll search the title. Just give it a go. Guess I click that button. This might do it. Right, it's playing. Right, let's give that a go then. Cool. So we want to add like that's not code. Yeah, so this line, let's make it a disk quickly, just for a bit of debug purposes of vec add, and then like mol s redirection with a bit of t. This is only if right, so if dot product between q, so that's squared length basically. Is less than radius times radius, so let's just give it a radius of like 1. Then we've got a disk hit. And then if not, we're going to return -1. Right, let's give that a go, see what happens. hopefully we see a disk now rather than a plane, and it can help us navigate what's going on. Well, clearly that's still wrong, isn't it? Something painfully wrong going on here. So I guess the next thing to do is just debug print some values out, because this just seems strange. What's going on? So if we simply just go right, I forget what it is, gpprintf, hprintf, position, I think we need the new line, pos.x, pos.y, pos.z, and then we'll do the same thing with normal. All right. Oh, the T count is right logic, thank you. Yeah, the T X. All right, bunch of ones coming out there. I did see some sort of other looking ones. What about the positions? Why are we only seeing normal? I guess that's because that's like a million normals being printed out, right? So I think normal's coming through okay. So let's look at the other one. Crying out loud. Yeah, that's what we expect, right? -7 or whatever it was. So they come through okay. What is like the hit T maybe? What does the T look like? Bunch of -1s. I don't know if it's always like that though, right? You obviously get some hits, right? Wait a minute. I'm accepting -1s as a hit. Definitely. So I've got to say like as hit. Yeah, usually my other ones. Yeah, if T is great, okay. If T is greater than or equal to 0, there's the problem. All right. So where's my disk? Then you got a radius of 1, by the way. I expected to see it down on the floor somewhere, but we're not seeing it anymore. So let's go back to the ray whatever code. And let's go ahead and probably delete all this that we added in for the disk code, because we didn't need a disk. What we needed was a plane. Oh yeah. Yep. Definitely easy to do. Everything is meant to be unsigned, you know? I never think about negative numbers. Right, I don't know what's going on here. Reverse plane. Alright, so obviously getting hits now everywhere. It's very difficult. Wait, Wait a minute, do these things always get drawn on top? They do, because they're not Z-tested. Damn it. Am I going to have to fix Z-testing? This is the problem. If I draw this plane, right, it's always going to draw on top of my stuff. I can show you it, right? If I position it, if I bring up the... Right, it's even drawing over the texture viewer. Great. We should be careful about where we draw this stuff. It's like one of the last things that happens, isn't it? Maybe we should draw the UI first. Easy fix. UI render should go last. All that debug stuff. So if we were to bring up the texture viewer, we'll be able to look at the surface. So you see in the screen texture in the texture viewer, so it's repeating. So if you go down to, right, so here's the scene, and it's always going to draw the plane on top because, wait, why is it doing that? The normal is going up. Oh yeah, because if it's down, I guess you're always going to eventually hit it. Is that right? Not really. That's not 100% true. Yeah, I don't understand why that is. So we could take the... Right, so the problem is the hit T is going to be kind of wrong. It's going to be... We've got to offset T, because that's going to get us the distance from vector. Is that right? No, it's not wrong. That's still the same thing, we've just moved it. Yeah, so that T is going to be fine. We can instead only draw the mouse position maybe and only print out that information. That's another thing we can do. So what we can do is say something like this, right? If mouse is mouse at, pass in the pixel coordinate. Now this code will only run if our mouse is hovering over that position, right? So we can also then do a bit of printing and we won't get spammed out like crazy. And we can actually output stuff like, well, we can print out, we say hit T. We'll just start off with that one week and we'll do more if it's not making any sense, right? So if we run that, my hit T is 0, minus 0, 0, minus 0. So it seems like the plane, like we're definitely getting some difference here, probably to do with how the plane should stop here technically. So that's definitely interesting. But we're getting 0 on the T, which is a bit bizarre. Well, So it'd be interesting to get something like... So the ray origin is 0 in view space. Hey, Devastated. Yeah, man, not doing bad, thank you. Yeah, not doing too bad. I had one of those days where I was just tracking down some bug and it was just long. But yeah, pretty good. Had a good day off yesterday, chilled with the boy. Yeah, I had a lot of fun. Yeah, how about you? So maybe we could print out this one. So it's ray origin take position. Ray origin is always at 0, 0. So if you've got a position of minus... Wait a minute. We did it on the Y, didn't we? That's alright, isn't it? Editor.c. I did it on the Z. Right, that's problematic. So it's actually just moving across the Z, which means that it's not moving. Really. So, right, that was dumb. Okay, so let's have a go at that now. So it should be moving up and down now, but we won't be seeing it. You kind of see a red dot if you're careful, but right now the hit T is actually moving. That looks like we're getting something sensible now. So let's drop that silly is mouse at, and we should be seeing a plane now at least moving up and down, right? Well, it's not moving. Oh, it's in view space, of course. Anyway, so let's move it to the world space one. And coordinates saying lots of room to be silly with. Cool, there's our infinite plane. So IQ also had this thing where he added to the the dot product, and it sort of, when I tried it in this example on Shader Toy, it looks like it curved the edge kind of. So maybe we could add something like that, because it might be nice. But yeah, I'm not really seeing it going up and down that much. Well, it's obviously like, I guess if I put myself closer to it, I'll get swallowed up by the plane. I'll find it. Hang on a minute. Ah, there we go. Right, so we did get the right normal. Yeah, it should be moving automatically now. Yeah, it's moving automatically. Cool. It's got this pool of lava down here. So we could do a thing where we color it based on how close you are to the center. I think that one's so much nicer. But we could try this sort of like adding of the let's check my levels out. That's alright. So in that chord shared or whatever, so we want to say something like, so you had this thing, right, where he added like a number to it. I think I put a really big number at some point. Let's do like 1,000 and see what happens. I don't know why, because that should be as... Why was it big on his one? It might not need to be that big in mine. Playing away from the origin. Is that all it is? Along the normal direction. But it made it like... I don't know why it sort of made it go round and I tested it. Yeah, I thought it was that, but it didn't seem to behave that way, but maybe it was just difficult to tell because it was the way I programmed it. Yeah, I can't really see it go at the edge. Makes sense. Yeah, okay, so that makes sense. I'm not going to want that, I don't think. Yeah, we've already got a position that you can define, and it works out from that anyway. Then you have a normal, so that's cool. The only thing I wanted to add is in the debug drawer. I wanted to add kind of like a distance based shading, maybe, because it will probably help viewing. So I think if we take the ray origin take and we do the dot product, we could probably put that on as part of the color or something. Instead, we could probably give a normal of the dot product between normalized in this case it'd just be negated position. And what else? And shoot. What am I trying to do again? So I kind of want, like, if the more the ray origin is over this way, the more like this. I guess it's the hit position, right? We probably want to shade. I don't want it just to feel like some flat plane. It needs to have some sort of shading to it, so that it's not so flat looking, basically. Maybe we could get the hip position and then get the radius it is out from the middle, and we could probably just shade it in some way based on the radius. Maybe we could do that. So hit pause might do it. Moles ray direction. Hit T. Oh, hit T would just do it, wouldn't it? Yeah, that just makes a ton of sense. Yeah, I'll do it that way. That's kind of obvious. Thank you. Oh, nice day off. Good, thanks. Been working all day. Been doing planning for the next off the move next week. Awesome, it's coming in. Amazing. Yeah, it's been a while, hasn't it? But it's not long now. Awesome. Is it just yourself, or are you getting some family to help you out as well? Oh. So, yeah, we don't need any of that. That's just a load of crap. So, what if we just... we take the color, we unpack it early. And we just have a bit of a play that way. Maybe we just go, take the color, dot xyz equal color we probably want to multiply it, right, by something, by some scalar, and based on the hit, maybe just sign it. Do a sign and see what happens. It might look very weird with the hit T though, but we can always have a bit of a play. Maybe we will do the other way. Let's just do this and see what happens. But that will make it go towards black, which might not be what we want, but we'll see. One of I by T, maybe. That'll make it fade out towards the distance, wouldn't it? But this one sign makes it repeat. Yeah, we could try 1 divided by, see how it looks. This looks funky. Bit much though, innit, on the edges. Boom, boom. Hypnotoad. Boom, 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 boom. Anyway. Hey Dora, how you doing? Yeah, it's alright. I'm a bit concerned about the edges, but it doesn't necessarily matter. So maybe we can make the wider. So I think if we multiplied the T by 100, make it a bit smoother maybe, is that how it would do it? Something like that. Okay, the other way around. Also Hypno floor. Alright, it's a bit better. Still, I don't know, maybe I just did the inverse and see what happens. Maybe the inverse would have just been better, like you're suggesting. Because... yeah. So basically we're trying to get a plane up. This is just silly. For debugging the gizmos, maybe the plane is the wrong tool. I don't know now. I think we might want to limit the plane to some degree. What have I done? Oh yeah, what's all this? Get out of here. Hey Glorissa. Contract was finished. Yeah, it needs to be... I guess if I did that, this would have to be scaled. See how that goes. Yeah, it does, doesn't it? I wonder if we could do... Maybe we could blend multiple signs together. I don't know. Not that one. That's alright. So you only really want it... Guess it's alright. So I was thinking like... What the hell are the rest of my objects? Well, I guess The Z testing needs to work, doesn't it? But didn't I break the Z testing? I did, didn't I? I think that's broken. Let's enable those, see what happens. Yeah. Right, so what is Z testing break again? Let's double check. Depth texture. Right, we don't write to the depth texture. It's simple as that. I stopped writing out to it apparently. Oh. Let's give that a go. Bit of maths. I don't know, it's called smooth T. Incredibly incorrect, but let's try it. All the math suggestions. I'm like, yeah, we'll see how it goes. I'll give it a go. Thank you, Cranston. And hey, how you doing? Right, let's give that a go. Hit T V space. Yeah, so clearly your algorithm just gave me a weird UI. I'm joking. Yeah, this is still the depth texture bug. But it kind of looks smooth in the glitch form. But yeah, let me just quickly fix that. So we don't run into the depth texture. Right, when you load, we never store. So I think we like a BVH ray tracer. I think we switched to it, but then we didn't. I don't know what we did. Shading, depth. Closest hit depth. Right, I've got some really dumb thing called like view oh my days. No depth texture. Right, let's get that one sorted out. Where it only I don't know, I did something wrong with my multiplication and I just fixed it that way in a very horrible way. Depth texture. Right, so in graphics, no, graphics.c. Depth texture equals GP command sync read write. Well, I could probably be write only to be honest, but this ought to be good enough. GFX depth texture. Right. That'll be good enough. Fingers crossed it doesn't break. So that should write out a depth value now. There we go. So stuff gets depth tested now. Cool. That actually doesn't look so bad. It needs a bit more of a thing here though, but that's cool. Yeah, same with like loads of math functions, right? Let's try another one. So the other one was like 1 divided by 1f plus some function. of t. But what's the sum function? What's f of t mean in this case? Right, t could just work. Okay, so I just inverted it the other way around. Nice. Right, 50 is that how far? Okay. Yeah, I guess we could power it instead. Yeah. Okay. Right, I don't want to spend too much time on this. Let's just get something that's useful. T squared might be nicer. Right. Maybe I just need to power it by a larger number. We'll see how it goes. Or not, power, rather. Right. Oh. Hit the floor. Yeah, so you need a... Yeah, because last time we did it as 1 divided by this. Because that just made it smaller, is that right? Yeah, so that's just made it smaller. We need it kind of... Maybe we need to do some square roots on it or something. Alright, let's give that a go. Yeah, that's maybe better. Moved away. Cool. Whoa. Nice. Yeah, maybe... let's stop the floor from moving. Probably quite a big issue. Let's try another one out. 1 divided by pal. 1 plus t. Something even smaller. So it shouldn't be moving now, so we... That's pretty nice. Pretty good, it feels much better. This is pretty solid. I might tweak a bit though. What happens if I make this number 100 times smaller? Does it make it fade a bit more softer? Or it's more hard. So if I instead do that. Yeah, one overwrites the other one, I will delete it. Right. That one's a bit too much. So if I made that a 2. Yeah, that might be it. I think we found ourselves a winner. Thank you, RCT. Appreciate it. I'm sorry, Cranston. RCT 1. There we go. That ought to be good enough. So as we get closer to the actual center of the plane, it will be more red. As you know, it's based on the hip T position. The closer you are to the plane, the more red it gets. That's it. Yeah. The further away the plane is from you, the blacker it gets. Cool. It's definitely much better. Just having a flat red color. Cool. Color. It is brighter when closer to the plane. Something like that. That'll do. I know it was like mouse, but Gizmos.com is really nice for playing around functions. Yeah, I've seen it actually. I just gotta get used to the syntax. Yeah, it's pretty nice to graph stuff out, isn't it? Yeah, something I should really probably play around with some more. That's very true. Right, so now I've got this plane thing. What else would be useful about this plane? That took way longer than I hoped. But it's there. So the reason why I wanted this plane was for the gizmos. These guys. Scary gizmos. Oh, for crying out loud, what's going on with this now? Depth testing. So those planes are wrong. So that's the OBB. So we obviously calculate the thing a bit wrong. So redirection in local space. I did decide to like normalize that here, but it's meant to be a direction. And then either hit T, bring it back into, and get the length, and that's the depth. Hmm. In a lot of game engines, when you go into model, it becomes transparent. You can see through it. Why don't you fix this? Yeah, because in game engines, they just model the surface of the object, right? There are like in there are some other engines like in Dreams where it's made out of sign distance fields, so they can tell when you go inside, and then they sort of make it look like you're inside an object where everything's a bit sort of underwater looking, where it's like gloomy. Um, but yeah, I guess some other engines probably can do something like that. We sent never seen this video. Oh yeah, I've seen this one. This is made by that guy who made that squirrel hash thing. Yeah, this is a cool video. Yeah, this is a good video. I might watch that one again. Thank you. It's pretty cool. Um, Right. So when I do my reverse box and I get back a hit position in the local space of the object, oh, you know what I'm not doing? No, I'm multiplying the vector. Yeah, so I'm getting along that direction, then transform the vector back into view space, and then take the length of that vector. Sounds alright. Then take the length of the vector. Why does the plane say it's closer though, you know? It seems to be as I move. Alright. That seems alright, yeah? So these seem to be kind of view dependent in a way. It's a bit weird. The plane ain't view dependent, is it? Because the plane was... What the crap is going on with these? What is going on with my code? It's like the floors are going under each other and they collect up. It's just a wonderful feature. Anyway. Okay. Yeah, so it seems like it's maybe not the plane. Yeah, it's still in wild space. So it's minus 2 down, that makes sense, and that one's just going to simply move the position in normal. Right, okay, good. So in here, when it reports the hit, it's in view space. And that's correct. Right, so maybe it is something to do with the OBB. Ugh. So you get the hit position in relative from that one, right? Maybe we can have a bit of a play around with this, but maybe I could do it the dumb way and produce the hit position and then translate that instead. Hit pos local space, which is the add of ray origin local space with whatever this is here. Then we transform that. translate position. This is the hit pause view space. Then I just do a subtract and a length between hit pause view space and ray origin, which is probably just 0 anyway. All right. So let's try that one out. Hopefully that fixes our bug with those. All right, let's bring these up. Still gets swallowed up. It's very strange. It seems to be with the see, it's not hitting it at all. So it's not reporting that it has been a closest hit, so it's not doing the animation. So why is that? So we'll definitely render the plane first, because the Gizmo widgets get put into the draw array after. So it definitely processes that one first. So the depth, so we do have a debug. Why don't we put the depth back in the wait, what's the depth in? The depth is in view space. Yeah, so why don't we put it back in the texture, just so we can debug a view in the texture viewer. Oh, got to be careful here. Needs to be a read write, and let's give that a go. All right, so now what we should be able to do is bring up the texture viewer, and we should be able to literally debug these values visually. All right, so depth. Right, so these are white, which means the closest depth. That's strange. You know what, let's not render the plane anymore. So it seems like the plane might not be the problem. This is electronic or techno music? No. Well, I have done in the past though. Right, so these ones still don't experience that problem. So look at the depth texture. Right, they don't experience that problem where it gets cut off. So it's something to do with the plane for sure. It's just super weird. It's all in view space. That's correct. There's a thing called test depth. Are we not setting test depth? That might be the problem. We're not setting test depth. Right, if Z test, use the minimum between the scene depth that you sampled or loaded, and then the closest hit depth. If not, it's closest hit depth. Okay. So it's interesting. So why? Why would that? Is the plane depth increased direction the reverse of the gizmo depth direction? The gizmo is on 0 y. Well, it says 0. Yes, on 0 y 0 z. And the plane is at minus numbers. I can maybe move them both above ground and see what happens. But the t value seems sensible. You know what I could do is I could do that test, do the mouse thing and print it out. I think that's going to be what's best now, isn't it? So I'm going to say if is mouse at ucord GPU hprintf plane, and we'll print out the hit t. Awesome, I'll play it when it's on Lupo, thank you. Yeah, so now we go to the OBB. And we'll print it out here. Now you're gonna get 6 hit. Wait, how many OBBs we got? What? We've got to disable the other OBBs we don't want to see. So I don't want to see. Let's go to graphics. Are we drawing those entity things? Get rid of these. These are the regions, the entities. Get rid of those. I want to get rid of all of them besides one. Shoot. Right. My insane crazy macros are complaining. Hang on a minute. Right, I did the wrong. I didn't. What's going on? Right, this one and this one. Huh? What's your problem? Oh yeah, hit t doesn't exist for OBB. It's hit.x. Alright, let's see these numbers. So the plane is closer here, but then it's not there. Bananas. How's the plane closer? That's clearly wrong logic. Hit t along that direction. Like, Hmm. Yeah, something wrong to the plane code, I reckon. I don't know. Have a look. What do you mean by normalized? So these two normalized? I think they're normalized. Give it a go. I definitely normalized the normal. Yeah, the normal is just one. Yes, his big small values are very small. The plane starts at -1, so -2. So they're definitely within the region of. Could it be how I'm doing my view from locals for these Gizmo pieces, you know? Um, they're doing some kind of. So I need to figure out which one is wrong. Well, the vectors are never in the. Never fail, right? So why is that? Is that because we're not doing. Right. They're not Z tested. Which means it's going to use closest hit depth. Anyway, okay. Right, so if they're not. Okay, so I think it's the OBB that's wrong. Because the vectors. These guys managed to do their ones okay. Right, these ones don't suffer from the same problem. So I think it's the way I'm calculating the hit depth on the OBB. Because it's only these OBBs that have the problem. If I move back really far, those vectors are still okay. So it's not the plane that's the problem. It's the crying out loud. Okay, so the problem is clearly the OBB still. Right, so what have I done that's wrong? So I inverse the matrix. Yeah, very strange. I inverse the matrix. I take the view space one into local space. So this one hasn't been. Graphics.c. So these matrices, we've definitely offset them. Right. Um, right, so that added a bit of translation basically. And then we combine the two together. And then that's our view from local. That gets into view space. And these seem to work okay without the plane, maybe? Hmm. So yeah, if we remove the plane for a second, how do those sort of OBBs look? I guess that's another thing we should test is let's put another one down and see how they look. Like, it seems like it stays in the right place, right? It stays in the middle of those two things there. Right, that distance is very great. It's a big distance it's moving by when I make it bigger and smaller. And I'm only making it bigger and smaller by a small amount. I think it's scaled by something that's, can you see it's like 20 odd now? That's big units. Like one of these men is 1 unit big. So when this is like 20 odd, yeah, that's bizarre. Okay, so I'm seeing some problems. So it's definitely, the hit T definitely has some scaling issues. So if we were just to place a box down without anything too crazy, maybe we've done something wrong with our view from whatever matrices. But yeah, I think we can find it quite simply. So if we just used a view from world on it, right, and it'll just be in the middle. So if we just did that quickly, so that'll be here. Maybe a bugger. Right, so let's try that one out. So it's just going to be a little puck at 0, 0, 0. There it is. All right, so it's still got the same problems. Yeah. So it's not to do with this logic, which is great. So let's quickly check our view from how we can click our view from local. It's in that camera file that we made. So there's nothing to do with scale in here. Scale's always 1. Yeah, I don't think there's any wrong with the multiplications of things, because or maybe it could be, right? Could our matrix code be wrong? Because like we get this problem. But things just start folding. But that's probably due to the BVH code, to be honest. It looks like it's clamping out at some distance. That's probably not a result of... this wouldn't get clamped out, will it? Yeah, so those are okay. I don't think it's to do with matrix, it's probably to do with the BVH. I think it's local to view space or something. Anyway. Something really dumb is going on. But that's a different thing. So, right. So nothing to do with scale is happening here. But are things ending up scaled for some reason? Can we not... Can we just translate? So what happens if we just did this instead? How does that look? Right, so we hover over that, they're still kind of big numbers, right? Right, and let's double check they're big numbers for a minute. Put that back. Let's go to debug draw. We debug print out, and let's find the vector one. So when we hover over a vector, we get a hit on the, let's say the capsule. We'll call this one the vector, just so we can compare the distances when we're a bit further back. Just to make sure we're the same sort of, the correct sort of theory of what's going on. So we move a bit further back here, we hover over that, that's 3. And then this one is, 40 odd. So it's an order magnitude out, right? Kinda. In that case it was, but that's probably just a coincidence. If we get a bit closer, yeah, it's an 11 behind there, yeah? I don't know. Maybe. Anyway, so our theory is correct. There's some weird kind of scaling thing going on for some reason. So why is that? When we create the... So when we do the draw 3D OBB, we actually pass in some size thing here, right? How big it is. And this is probably the issue. So I think we're scaling it, which means something else has been messed up. So, right. Right, so we're scaling the axes by the half dims here. Is that the wrong way around? Well, maybe it's correct. It displays correctly, right? It's just the distance is wrong. So I feel like we're not getting whatever it is right. We've not done the correct thing with the scale or something. It's a bit weird. So the whole job of the OBB one is to move it back into the local space of the object. Right. I know what we're doing. So what's happening is when you multiply the position, so this is a unit AABB that we're trying to, so all this OBB, which can be offset and rotated. Well, okay, it's got a transform where you take it into view space, and it uses the scale. So essentially in local space, it's an axis line bounding box. That's a unit sized ABB, right? And all this transform does is it uses scale, rotation, and translation to move a view space from view space into... Okay, sorry, it's the other way around. It uses obviously it's a matrix that takes you from local space into view space, and that could be some rotated. It then becomes a rotated box that is of any size along the XYZ, right? Due to the scaling and rotation and scale. sorry, scale rotation translation. So when we inverse it, we're going to go back to a uniform ABB, like a normalized one, which goes from values from 0 to 1 across every dimension. So then we're doing our ray verse axis line bounding box, right? And then that hit has been scaled by whatever the sizes are of the gizmo things, which is 0 point whatevers, right? So that seems sensible what's happening. So I was thinking, right, if we do multiply p the other way around, it should invert it back, but it seems to not be doing that. Something else is happening, which is bizarre. So if we do the ray origin, right, that we had, plus, yeah, so I think it's something to do, is it because I normalized this bugger here when it, maybe. I did that recently. Did that today, actually. Right, seems to render the same. Yeah, okay, it was that. I normalized the vector when I shouldn't have normalized it, so I got rid of the information. Right, problem solved. I shouldn't have normalized that vector. What about the other one then with the ellipsoid? An ellipsoid in there. Right. I did. It was when I needed to normalize that other one. I was like, oh, I need to normalize all these guys. And it turns out it was completely wrong. Completely dumb. Right. Do we do it with the torus, though? Torus. I think we do. Alright, I think we're good. So, back to trying to do stuff with gizmos, and I've just been working on debug stuff. Right, bring back our gizmo. What was we trying to do? So we've got that plane thing now, which is kind of nice and helpful. You know, we could bring back the plane thing as well, editor, whatever. Well, hopefully it's nice and helpful. I was thinking about how helpful is it actually. So we've got this plane thing, right? Sweet, these can get swallowed up now. So maybe what we can do, I guess let's just start doing some of the code, and we should be able to debug it now. If we put the plane actually at 0 in world space, it shouldn't be a problem, and we can literally just write out our variables and debug draw them in world space and see like them in action, hopefully. That's the crap is going on here. Right, I have my camera in there. Cool. Nice. So whenever we put our ray down, our camera, we're gonna get our camera ray, and then we're gonna sort of like get it hit on the plane, and then debug draw that maybe at the hit point or something. Just some tests to make sure it works. Because last time we tried to do it, that was something that was a value which was probably wrong. But yeah. Right. So the thing I wanted to try out was we want to get the mouse ray, and we're going to do a ray versus plane test to get a position on that plane, and then we'll be able to use that. Okay, I did describe this last stream, but let's do it again quickly. So the way I want the logic to work, so we're trying to do the input logic for the gizmo, right? So right now we don't really have any code where we can click and drag. We're trying to write that now. So when we click on it, we probably want to take a backup of where the gizmo is right now, and probably where the mouse position is right now as well. Okay, and then we can use that to do a ray versus a mouse ray for this pixel versus plane, and that will give me a position in world space on this XZ plane, right? This XZ plane here. And then when we move the mouse, we can also get another ray versus mouse plane position on the plane. And then with this one and this new position over here, we could take this direction in world space with the direction to this, with the vector towards this mouse position, and do the dot product, and we should be able to remap it back onto this this axis here, and then take the difference between those two, the original position and the new position, and that's how much you move the unit by. So that's what we're going to try and achieve, and then obviously the rest of them kind of work that way as well. So we're just got to start by getting the code for the mouse ray thing. So thankfully I've already got that code. So in my shaders, I do ray direction for UV. We're taking the field of view, and I take in the screen dimensions, and then the coordinate, the pixel coordinate, right? So this is actually a very terrible name. I want to actually take it out of here, and I want to actually put it into my core shared. One says accessible on CPU and GPU. And what I would like to do is get the ray direction for pixel. So field of view on the camera, the dimensions of the screen, and this should actually be the pixel coordinate. UV typically means 0 to 1. This is not that, right? This is an actual coordinate. So right, so divide by 2, subtract. So you divide by, yeah, so you're taking away a half. And then you'll get doing, let's get rid of those. What am I doing? That should exist. There we go. Nice. So we're actually going to swap out that function. Maybe we can shorten it a bit. So where we have that old one in the shaders, let's grab it, and it's now ray direction for pixel. There's a lot nicer name. I've only done it 2 places, apparently, in the BVH ray tracer and the debug draw ray tracer. But yeah, so we're going to get that mouse ray now, and just see how that looks. So if we say you want to get the mouse, here it is. So let's go ahead and move in. No. Let's get this here for now. So what we're going to do is get the mouse ray. So redirection for pixels passing the field of view, that's in the editor camera. Field of view, the dimensions of the whole screen. Yeah, where's that stored? Well, I've got these things called like temp display width and temp display height, and that's in game.h. So I guess I'm just going to hard code it and let future Henry, when he adds window resizing, solve that problem. And then pixel coordinate, that is mouse position. So that will then produce us a super lovely mouse ray. So we should then be able to do a ray verse plane. So hit, that'll be the ray 3D verse plane. So the ray origin, this is in view space. Well, so this can be in whatever space I want it to be in, right? Ultimately, I want to get it into world space. Really? Is that right? Well, I can move the other stuff into... No, I need it in world space because the Gizmo works on a world from local basis. Is that right? Yeah. I need it in world space. So realistically, we're probably better off with, in my camera, I'm probably better off having a world from view as well. And then camera. Alright, this will be better. So, just a bit of a quick tidy up as well along the way. When we set the camera, we can just use the one from when we pass into the payload, the renderer. We can just use passing the one we've already calculated here. Okay, so back to the editor. So it's ray verse plane. So we do the ray verse plane. We need the we want the ray origin. Wait a minute. We already have the position in world for the camera. So that's already a thing as part of the camera. So maybe we didn't need to do that, but oh well. Right. Camera dot position in world. Nice. But then there's like a ray direction. So you need to move that into mouse ray direction world space. Multiply vector what are we doing again? We're doing it from the editor camera. So we're moving into world space from view space. This is that one. Now, this one would be ray direction. So mouse ray direction world space. And then the position of the plane. So the plane is just going to actually sit as 0, 0, 0 in this case, but the plane would probably be the gizmo's current position when we change it. So we'll just leave it like that for now. And then the normal is going to be whatever the normal we decide on. So I guess what I want to do is fill in Gizmo or plane, pause, and then plane normal. And these are things we're going to select based on which planes we need to test against, depending on which gizmo arrow or puck we've hovered over, you know, and clicked on. So we're just in the default one for now, and I did the normal wrong, so we'll correct that. So the normal will be 0, 1, 0, so point up, and then we get the hit. With the hit, we can calculate a hit's position in world space. So I could say hit pause in world space. So that would be an add from G editor camera position in world plus the scale of mouse redirection in world space with the hit T. Cool. So with this hit position in world space, we're going to debug draw it. So I have one of these. So rather than plane, it will be sphere. So we'll use a sphere to debug draw it. And the position is going to be at hit pause. The radius will probably be quite small, like a 0.01 or something. And then color red, and we will Z test. Sweet. So hopefully this works out. Well, color red's bad, isn't it? Excuse me for a minute. We're going to make it green. Well, some people might be green-red colorblind, but yeah. Apologies if so. Right, so we clearly see a green. This is good. Hey, no idea. How are you doing? Right, so we're clearly seeing a bit of green on the plane. Pretty lit. So we should be able to use that to work out some things. Yeah. Yeah, but it's good to also know that's not a problem. It did work out first time, which is kind of sad. We just spent time getting the debug tools working and it worked first time, but I'm sure it'd be helpful later on as well. Working on task system, awesome. Getting close to the first test, sweet. Yeah, that was a good good chat we had in the Discord. I liked it. Good fun. We ended up like talking about hyper optimization in the end. Yeah, classic. That was good. Are you going to test out those different solutions, or are you not going to bother? You're just going to pick one and roll with it. Right. So now what we would like to do is kind of get this. So I guess let's just get the X1 working, and then we can. So yeah, I tried it in screen space before, but if I worked out that it's better to do it in world space because it works with more of the things. Like they share more of the code. So yeah, how are we going to do this? Let's move this in here first. I can test the two queues. It's easy to write the other solution. Sweet. Yeah, I guess you'd have to do like an empty task and just run like, you know, a million of them or something, you know, and see what happens. Quite easy to test, isn't it? Right, so you always need the mouse position. So when we do a press, oh, this is it, isn't it? Hover and pressed. So you do hover and press, we take down, we should really take down where the mouse position was as well, but maybe we could do the reverse thing on, yeah, but it's a different plane depending on what. You always want the mouse position first, I think. Is that right? Yeah, I think it is. So I think we want to say the pressed mouse position. All right. So simply, that is just going to be something like this code here. All right. Chuck that one in there like that, as you do. Right. So with this, then we can get the old mouse position and the new mouse position. We can dot product them both. We get the vectors from the we're taking the difference, so it's the new mouse position and the old mouse position. So yeah, ultimately what we're trying to calculate is array verse whatever, and the plane would be gedit gizmo dot pressed. No, not pressed while from local. It would be the gizmo dot world from local, right? The current one in this case. And the normal, I guess, will be this one. Yeah, dot translation. So this will be the first hit, or the hit that you're currently updating where your mouse is. Then you do it again. And you're doing it with, this time, with the old one. So you do old, guess we do all of this. So that's the old mouse position. Old. This would be pressed where we pressed it at, right? That will probably remain the same normal. Not gonna lie. This is probably set in some other piece of code because we're gonna share this code basically. Right, and then you get another hit. That's based on old plane position. Wait, is the plane position always in the right? Hang on a minute. Plane pos is probably always based on where it was. It probably doesn't actually matter. But yeah, we should use the where it was initially coming from. Something like that. Right, so that goes there. There's less variables there, that's good. Old mouse direction, and we'll stay on that. Hang on a minute. Yes, the ray play. Okay, good. So ray origin, ray direction, plane, normal. Cool. Right, so this is the old hit. So we get our old pos and our new pos. So why don't we just quickly draw those, both of those out. we're going to do a green and a blue one. And so the blue would be the old one. Well, let's do like a... what colors have we got? Do a teal, slightly different color, because the problem is the blue is the axis I was clicking on, wasn't it? So if we try that, we should get some kind of thing happening. Right, so we click here and then drag. Right, I think it's been Z tested. That's the problem. It gets Z tested with themselves, doesn't it? So if we make these actually a bit bigger, that way they'll poke over those. Hopefully they'll poke over those arrows there. Right, I'm not seeing it there, which sucks. I don't know why. Did I not make the mouse? Ah, the old mouse puzzle's the same one. Right. Big problem there. Let's correct that. Right, see how that goes. I saw it pop up. Huh. This is just weird. What's going on? I'm not using the old redirection thing or something. I don't know. Something that's wrong. Cool. So it's kind of working. A little bit off. They're kind of tied together in some weird way. But they are definitely separating now. So there's another one where I forgot to use an old whatever. Maybe what's problematic is the fact that the camera is moving. So you probably want to also keep track of where the old camera position was. So if I do it where I lock the camera, it'll probably work okay. Yeah, perfect. When I move the camera, it fails. So that was obviously another problem there. So pressed camera position in world or whatever, right? So I need that. That was quite handy, that debug stuff there at least. Camera position in world. So I will do the sort of G editor camera position in world, yeah. So vector 3, it's 3 dimensions. So this one here is Gizmo. There's a couple of places where it does that. It's here as well. Yeah, so Gizmo, pressed camera position in world. Right. So that should be it, hopefully. We should be able to move around the camera as well, and it still will... not that we should probably support that feature, but it might be a bit... What else did we mess up? Right. I need to keep the old view ray. It's obvious, right? So if I got the old camera position, I need to keep this same old view ray. So what am I doing with the... Why don't I just keep the old world space coordinate? Why do I need the... Why do I need all this stuff? What was the reason again? I just need the old world positions. Why did I want the mouse one? What was the reason for it? Oh yeah, because I don't know what plane you want to do it on in the first place. Yeah, that's why. Because you might want to use a different plane. So what we actually need is a camera. Well, if you just keep the old, you can keep the old view from world, or you can keep the old. Um, yeah, if I keep the original view from world in here, world from view, that'll do it. So yeah, another matrix. World from view maybe. So when I click it, we take a backup. Some matrix. Then we take the press position. All right, so use that one there. I guess I'll keep the camera position as well. That's all right. So it should be it. Sweet. I'm able to move the camera. The blue sphere stays there. That's where we initially clicked it. And the new one is where we're dragging to. So we should be able to get a couple of vectors to these guys and work out how much have we moved this along the x axis which we clicked on. Nice. We're not too far from that now. Sweet. I'm just going to take a quick break to get another drink. Then we'll wrap that one up. All right, BOB. Alright, welcome back everybody. So I reckon now that we've got these basics in, the rest should just fall into place really. As soon as we get one of these axes done, we should be able to get the whole translation thing at least working today. I'm hoping to get it all finished. Scale shouldn't be too far off. And rotation shouldn't be either. Because on Sunday I really want to work on that color picker. You know, so let's hopefully get this done. So, right. So what we need to do is get the vectors to each of those hit positions along the plane. Right, so if I click here, we want to get the vector from this base position where the vectors come out from towards that one and towards so that cyan one and this green one here. And we will need to get the so we get the vectors, we project them back onto that plane, or the X. I keep calling it the X, but it's the Z. Anyway, the Z axis, project it onto that one there, using the dot product, and then take the differences between them, and that's how far we move it. So, shouldn't be too bad. So we get one which is called vec. So this would be the subtraction from we're going towards hit position from the editor dot gizmo the original world from local translation. Okay. Yeah. So we're hitting. Yeah. So it's vector going from that base position to this new one. Then I think we want to do it the same way where it's the old position. We're on the old vector, right? And then we want to reproject that across. So I guess I can call it old T. Or call it T. So we do the dot product between the direction. So it's the normal. So in this case, it's the Z that we was testing. Yeah, it's setting the Z one up. Right, so the dot product between editor gizmo and we want to be doing the world from local again, because that's what actually the gizmo is, right? It's the world from local transform. Right, where do I get my basis vectors from again? How did I do that? So that would be your rotation. Yeah, I've got the code written already. It's this one here, multiply units. Sweet, so we wanted the Z one. Anyway, any of these will do. So you'll produce this. Let's do the Z instead. So how much does that project across the direction? The axis direction. Right, G editor gizmo, cool. Then we want the old T. And then we simply just take the difference between those two. And then this is how far so we're going towards the new one from the old one. And this is how much we offset the current axis. So in this case, it would be, the Z one, right? So it would be gEditor dot gizmo dot right, so the problem is the current one of these. Yeah. You always want to use the pressed one. Yeah, good. Right, so this one will then say the translation.z is equal to whatever the old one is plus the difference. Plus diff t. Neat. That should be working. Fingers crossed. Bit of maths. Oh yeah. Maths. Now I gotta let go. Let me go. But yeah, so we only got it working on the Z. But the rest should just translate. We just gotta switch it all about. That's pretty nice. Success. So when we have not pressed, we want to like not do something like, so if it has been released, we just want to set the hover to none. gEditor.gizmo hover pressed, rather, I meant to say, equal to none. So I forgot that was now. It's graphics gizmo hover none. There we go. So yeah, this hover none basically just gives us which component we're hovering over, the X, Y, Z, or the plane X, Y, that sort of thing. So yes, that will now work, right? So I guess let's just do something else. Let's try and generalize it to make it work across the X, Y, and Z. So the way we're going to do that is, or maybe we can go all in and get it just working for the XY plane as well, or the planes as well. So what are you doing when you drag the mouse above the plane? Oh, you mean when I go off the screen? Yeah, that's a bugger, isn't it? Yeah, that's a problem, isn't it? Yeah, we've got to detect that. What would your t would be infinity, wouldn't it? Or it's negative in that case, isn't it? Yeah, because t is negative. Yeah, so if t is negative, you probably want to. What you could do is the x-axis, you hit test against the YZ planes. Right. Interesting. Not a bad solution, maybe. So let's figure this one out. So maybe let's get some a little bit of visual up rather than brain visualizing it. Yeah, so rather than doing the crest, so this is the Z one. That made me feel like I was moving rather than this thing. Confusing. There we go. Yeah, so rather than doing across the XZ plane, what you're saying is test against the yx plane. Or the yz plane in this case. And then take that x value. Yeah, 'cause you're projecting against the same plane. Right, yeah, that's a good point. And then you would never get the problem. No, you shouldn't do, right? Yeah, so for the z plane you do it against... Yeah, that makes sense. Right. Hmm. Yeah. Right, you do the Raycar's closest approach. Right, I see. Yeah, maybe you could just do a different plane. I think that's... Or do a more correct plane. Yeah, maybe that will work. We can debug visualize the planes as well and see if it becomes a problem. Yeah, so let's wire them up. So we need to do one before. A lot of this is shared code, which is amazing. So we literally just take this switch statement. Right. And the only thing we need to switch on is probably to get this normal. So so effectively, if you hover over the x1, you want to be testing against... Oh no, you got to do against two planes, isn't it? Maybe. And then take the minimum. Or no, it's the max. Or the min. Because the problem is that it gives you a negative on the... You might have to do 2 hits on the planes. That'd be kind of annoying. Where's the x? Hmm. Yeah. Could we slant it across 2? No, you'd have to do... You'd have to do 2 planes. You can't slant it either diagonally because you could look at it the wrong way around. Wait, could you? Hang on a minute. What happens if we did it diagonally? Then it should be okay. That'd be an interesting take. No, it might not be if you go the other way around. Let's give it a go. Right, so forget these things, so I've got to... Right, diagonal that and that one, and I've got to form it. I don't know if that would work. Crying out loud, you bugger, what's going on? I'm not debug drawing it. Instead of planes, you could do closest point along the axis line from mouse radius. Yeah, that's the other way, isn't it? But that will work great for the axes, but the other one... But for this one, you need the plane, isn't it? Why isn't that working? Oh, didn't recompile it. Yeah, maybe we should use it for the axes ones, just do the closest. Yes, that one I'm doing a diagonal, right? A diagonal plane. But if I go to the other side, is that still a problem? because might put my head through the plane. There's not an issue there. It's done some weird stuff though over here. What's that? Oh, yeah, it's probably the clipping. I don't know. But if I did this, yeah, I'll still get the same problem, isn't it? You could equally just do a plane based on the position to the camera. Right. Could that work for all? Could that work? So all the ones you could just do uh, your normal, which is basically the direction to the camera, and that should solve it. So for all of these guys, you could be like, wait. Okay, that might not work. But it's close to the idea of what we need to make it work. So if you got the Z plane, you want um you care about it going down the Z, but you want it to rotate around the Z type of thing, isn't it? The what's the way of saying it? I think you want yeah, 6. Yeah, all right. Be right back. Right, welcome back everybody. Yes, had to help the wife with the boy. He woke up and is a little bit warm. But we think we found out why. So we're all good. Yeah, so I was thinking if we take the plane that we use to test, we can move based on the camera's position. So if you take your plane and your camera is here, the normal needs to go to that towards the camera on the axes which the so if I click on the hover Z, we need to use the Z axis and then the XY. So it's something like the norm of the position in world space G editor camera dot X. So I think maybe what you can do is you can just set it to be this. And then you can just change it to be, so you go like, hey, well, the plain normal dot, in this case, we just want the Z to be 1. And then we normalize it with itself. And then that should be, wait a minute. Maybe do like a very small number just in case. Something like that. That should work. That means the plane is going to be following the camera around a little bit. So it should mean that we'll never get any problem. Well, we just got one. Right, so that's... Why is it so strange? What have I done wrong? Camera position in world is got to be relative from the plane's position. There's probably the subtraction of subtraction of the... So we're going towards the camera from the Gizmos position. Maybe, something like that. Way too dank. You still kind of get it. I think it looks alright. That's definitely not the right plane that I asked for. But you will still get it, kinda. That's not the plane I wanted. Yeah, with the ray approach, maybe. Yeah, maybe we could switch to that. So this one is definitely useful for the planes though, and it's probably useful for the rotations. Closest point on ray maybe, isn't it, with another ray? It's not really for a point. Ah. Oh, amazing, thank you. Appreciate it. Ray. Ray closest. Amazing. Cool. Appreciate it. So with another one. Ray intersection, I guess. Ray versus ray. How many ray versus ray is it though? It's just ray versus ray closest point. That's the best I got. So returns a vector 2. So are those closest points on each ray, isn't it? Interesting. I see it. A will go far along B. Yeah, that makes sense. Doesn't make, yeah, maybe it makes quite a lot of sense if I just read it. It seems quite simple, right? It's just dot products across. You're just reprojecting. Yeah. That's cool. Yes, I guess A. A direction, B origin, B direction. Alright, so we want a bit of a result. Hey, what's going on there? There we go. So A origin and B origin. Then it's just the dot product, a bunch of dots, A direction, B direction. Wait, why have you dotted A direction? Ah, A and A, that's it. A, B. Right, so you got the squared magnitude. So A and C, the squared magnitude. No, they're not. They're just of the. Why would you do that then? Interesting. Right. Yeah, I don't quite understand the code, but fair play. It's line, not raise, but you can see the result will work with alpha closest. It is array though, isn't it? Like, what's the difference between an array and a line? Because they both go backwards and they're both infinite, right? Well, in this case, right, it's array, it's infinite. Whereas a line has a fixed length, doesn't it? Like, array can go backwards. That's, I guess. Well, like arrays always give you the a front and back value, right? I'm not sure about the technical terminologies. Yeah, maybe because it means array just goes in one direction, like if you think about it. The pedantic line is infinite in both directions. I think the segment was fixed length. Now I'm just super confused, Glorious. But yeah, I thought line honestly was segment. I thought they were the same thing. Like, I thought a line was a start and an end position. And then I thought that's what it was. I don't know anymore. I've clearly woken up in a parallel universe. They've got a capital D. I'll follow suit with a capital D. Yeah. Line has 0 fixed endpoints. Array has 1 fixed endpoint. Segment has 2 fixed endpoints. Right. Maths. So that obviously stops the divide by 0. Nice. Return. I guess you want to return zeros. Right, so then r.x is equal to this maths, b times e, c times d, d. Right, let's try this out. Hopefully it all works out okay. A, E, D. Right, let's give that a go. So we're still going to keep the code that we have for the planes. But for the axes, they want to use this code. So what I'm going to do is the axes need to talk about the planes to calculate their closest hits, right? So what we're going to do for now, you probably always want this to some degree. Here. So this is going to get go here. Right out loud. Let's drop that in there. We'll come back for in a sec. Yeah, I think that'll be right. Wait, camera plus T mouse ray. And B will be selected axis. Well, yeah, and you'll get the T values back with those. So I think you would do something like, so for these three you need to get the axis vector. So another switch again. Well, implemented now. So if you've seen in Unity, you've got Gizmos, right, or stuff like that. Other game engines, 3D applications. Sorry about that. I wasn't trying to brainwash you there. So we've just been implementing these guys here. So, you know, translation widget thing, it's called a gizmo, and a rotation one and a scale one. So I'm just trying to work on the code which will sort of like do the dragging and stuff like that. This is what we're trying to implement. Yeah, it was correct in English. Line is infinite in both direction. Right. I'm confused. Maths people. Maths. Right, so we got our axis. And then we obviously need our brakes in here. Let's just get this in quickly. Alright, so bit of a break, and another break, and another break. So seems alright. Now we would like to do the so we only really care about one result, and that is the T along. So we take the two rays. Okay, so first one we need to actually produce where is it? This one. I need to move it into into the space, world space, local space. Cool. So if we take the two ray directions, the camera, mouse ray, and we just want to find, we want the Y result, I think. So we'll call it T. Yeah, I think so too. Ray versus ray closest point. So A origin, which is the camera. So Geditor dot camera position in world. And then the redirection. So we've still kind of got some of these here actually. I think some of these are going to be shared. Mouse redirection in world space. And then the other one is the position of the gizmo. So Geditor dot gizmo. Now we want the pressed world from local position translation. So I guess we could just say, we could probably shorthand this because it's probably going to be used in other places as well, maybe. We can call this the old gizmo position. And that'll be just shorthand, so it's just less wide code everywhere else. And then we've got the direction, so in this case it's the axis. Then if we do a dot y, so when you take the second result, so then that should be our hit t along so that's our world space position here. So that'll be, you add from the old gizmo position along a scaled axis with t. Wait, why did I want that? Why am I making these two positions? I don't need that anymore. That's overkill. All I need is the difference, and then you add the difference to the base one, and voila. So it might be as simple as you do another one. Old redirection. Gizmo pressed position in world. Press camera position, old redirection. Nice. There's your old T. Take the difference and then simply offset based on, you need the yeah, so I guess you want to do another switch. So in this case, you take this line. So X, Y, and Z. Kind of long names, but oh well. Rightio. Okay. So that should do it for the these guys. Then these are the plain ones. So I think I'll move the rest of this into the plain code. Just so we can see how it works, right? If the other one works, and then we'll get to the planes after. Right. Okay, just give that a go. Fingers crossed. Right, so we click and drag. Right, we did something clearly wrong. Oh, we didn't update the recompile. Oh, the negative t's, of course. Forgot about those. Thank you. Right, so if... No, negative t's are what you want. Right, we want negative t. Because we're going from where the gizmo initially was. Wait, you'll never get a negative t for... Wait a minute. Yeah. So we want the negative t because from the old gizmo position. So where the gizmo initially was when we clicked down, and it's going to be negative sometimes. It's okay. Right, it seems to be working. It's the wrong way around. So some, and then like also, it's something like only working when we. What's going on? Bananas. Right, if you've hovered over it, right. We want the pressed logic. Right, so the coordinates are the wrong way round. Yeah, that's looking way better, isn't it? That's lit. Thank you, the RCT. Appreciate the code there for that one. But something seems flips the wrong way around. So the T's are the wrong way around. So I guess the problem might be we flip these the other way around. Maybe. What was it saying? B, C, D, E, C. So I think we could probably flip. Yeah, I don't know exactly, but let's just give it a go, right? Maybe we could do that and it flips the sign. Obviously you can negate the result, but I think this will do it as well. Or flip D. Yeah, I was thinking about D, but then that would... I don't know. I want to try this one out. I've already written out now. Yeah, that works. Nice. Let's go around from the other side. Gizmo. Ain't it beautiful? Oh. No one saw that, right? Yeah, that's a bit strange. Is that an infinite problem? Oh. We have got some negative t's then, no problem. Or is that because I did the flipping thing? Yeah, so if this one is... It returns a 0, doesn't it? Or something like that. I was wondering why I was calculating the negative of a determinant. Hmm. Hmm. Or when behind camera. I don't think we need, do we need to solve the behind camera one though? No, yeah, okay. So it's only Yeah, the old ray is fine. Is it? So I guess if I get t, if old t equals is not equal to 0, I don't think that's going to solve it fully. Let's have a play, see what changes. Wait, it's not old t, it's new t. Because old t is never going to be a problem. Then we should print out some values here. Yeah, they go negative. But you want them to be able to go negative, right? Right. Hmm. I wonder what that could be. I know what's going on. So what you got is two lines, right? You got your axis vector going this way, right? And so when you have your view ray going like this, it's like, well, my closest point is there, isn't it? Right? But when your view ray is going like that, right, your closest point is negative along the other way. Blom, blom, blom. So we'll solve that problem. And top left that you're in UI. Yeah. So we've got it's on the VOD channel. But we built a custom rendering thing which is with sign distance field. It's got some crazy sign distance field renderer. This is the texture viewer that I've written. So we can view stuff, right? And yeah, it's got basic widgets, drop downs and stuff. It's even got popovers, right? This is a popover. It's got text inputs and stuff, styling. So we're going to be using this for the editors, that is for sure. You know, it's all right. Does the job. Yeah. Media mode. I can drop a link to the VOD channel. You can surf around. I think it's like episodes 40 somewhere in there. Where we built it all. It's quite early, I think. Yeah, so I wonder if you can check if the new position direction is facing away from the camera and reject it for now. Yeah, I think that's what I might do. Like, so if the if you take the dot product between the two, No, you can't. I wonder how you'd do it. Is it with a dot product? It's not really with a dot product, is it? It's a... If you take the cross, maybe you might be able to do something. Oh, the camera T value, right. That might work. Oh, the camera T is negative. Ah, of course. Of course. Common sense. Right, so we want axis T. Alright, so we'll call this T's, old T's. So we'll get all the values out and named. So we have the axis T equals TS X. Old axis, wait, sorry, this is camera. Whoops, wrong way around. They're the Y's. Y's, 1. So these axis ones are camera. Camera AT. So if camera AT just the new one. No, this is like my 4th or 5th Vulkan project, I think. I tried to write like a general renderer a few times, and I've done some game prototypes and things like this. But yeah. Sweet, that sounds pretty sensible. Now it's not clicking. All right. I don't know what I did wrong. Yeah, it's just going to put it back to where it was. Oh, there's nothing. Yeah, we might put it. Why don't we restore it back? But still, it's weird if it's less than 0. Um, confused. Hmm. Yeah, I don't know why this is wrong. Just put it the wrong way around. Yeah, I think if it goes behind the camera, we just want to set the position back to where it was before. Before you, so we just restore the whole Gizmo translation back. So it'd be something like right. That could be right. Maybe the T. Hmm. And then we'll just restore it back if it's wrong. The ordering of the elements in vector results is opposite ordering to the function args. No, because axis is the second lot that go in, right? But yeah, we did flip the code the other way around from what it was, though. We did do that. But BE takes CD. Yeah, I don't know what it is, to be honest. Hmm. I think they're okay. I think they're the right way around. Because, yeah, actually, so I think we want to flip Y's but not B's. Sorry, wait, I'm not sure what I said. Anyway, we want to flip Y but not the X one. And that'll give us the right value, I think. Right, so if the camera T is greater than 0, then keep it, and if not, just use the old translation. Right, so that still works. Then we'll go off screen, and it should restore it back to where it was. There you go. So you go off screen, it puts it right back there. So you should hopefully not be able to lose it. Well, you can always lose things off into infinity, but maybe there's a difference that is too far that we can do, right? That's always a possibility. Clamp it off at some distance. Cool. Right, it's pretty good, isn't it? Right, it's kind of getting super late now. I wanted to finish this off, but it's not been possible. So what we'll do is we'll finish off the rest next time. The plain one's going to be super easy. We've already got the code for that. It's not going to be too bad. The rotation, I've still got to figure out what I want to do for rotations. Yeah, rotations are going to be an interesting one. I was thinking using polar coordinates, but there's probably better ways to do it. Scaling is going to be super easy. And then we should be done. So hopefully on Sunday. Yeah. Rotation is going to be an interesting one. I was thinking I could probably do it across a single axis. Pick the best axis or something. And maybe I'll do a visualization for it. But yeah, I guess we'll finish that off on Sunday. And then soon we'll get on to do the UI color picker. So yeah, about 5 hours ago on Sunday we will start. That's cool, Cranston. Take a quick gander, but here it is. So A origin A direction, B origin, B direction, right? So it was the camera's position plus the camera's direction. Oh, the call site. Damn it. Yeah, camera position in world. Then where the gizmo was pressed at, or the camera's position at that point. Mouse redirection through the camera, and the old one through the camera. Then the old gizmo position and the axis direction. There's one ray. There's another ray. So these are your X's, these are your Y's. Right, X's and Y's. It does make sense. Yeah. Yeah. It'd probably be refined a little bit more, but yeah. It's the original state when you pressed on the gizmo. And we just back up a lot of stuff at the moment. Probably could be cleared up a bit, but it's alright. Cool. Right, so let's bail. I've got to go. But yeah, hopefully you guys have a good weekend. I'll see you all on Sunday. Maybe we made last miles. Rightio. Catch you later, guys. Thank you for your help. Thank you so much. And I'll see you all soon. Bye.